Hello everyone! I want you guys to try to solve this problem before we start. So let's begin. Let's first understand what we should do. We need to get a grasp of what the upper and lower bounds should be. So you should think of a line and a quadratic function if you were trying to solve it like the graph shown here. The function should lie between these two functions shaded blue. However, because the k is for all integer, the actual function should go through all the lines that is showing on the right. The red functions like these does not meet the condition. Whereas the white functions meet these conditions. Now, what we have drawn were just an estimation. We should know if the function can have intersections or not. Therefore, we solve for lower and upper bound. If we solve for this k, we can see that the intersection happens on k equals -1 and -2. So, we should draw the function having two intersections. What we can derive from this idea is that the function will always have to go through a point k equals -1 and k equals -2. Therefore, we can derive two equations. Now, let's think again what we are given. We are given that the function fx is cubic function with leading coefficient 1. Meaning, fx will be written like this, having 3 unknown coefficient. We need to know the value of f'3, so if we differentiate the function, we have to know two unknown coefficient a and b. Now let's go back to our inequality. If we carefully put in k plus 2 and k in the function and subtract it, we can easily show that the result will be some function not containing c. What that means is that the two equations we have found will be giving us the solution for the coefficient a and b only. Let's put in the numbers and solve it. If we put in the values, you can check here that the coefficient c is erased after we subtract the two functions. Solving these two equations gives us b equals -11 and a equals 5/2. Therefore, we can find the value of f'3. So then, what can trick you in this question? If you change the function in between the inequality like this, you might have fallen in the pitfall. What this means is that in a function fx, it is the slope starting from point k to point k plus 2. As k changes its value, the slope changes its value also. However, the lower and upper boundary is really hard to interpret it with slope. I've drawn the slope of each lower and upper boundary in white with changing k. As you can see, because this is the answer, the slope will always in between these two white lines. However, you cannot easily imagine this in your mind, and you cannot make any equation using this fact. Therefore, if you use the slope method, you could have not found the solution of this function.